Number 5 on the lecture examples says if the KEQ for a reaction is equal to 0.00872 and the initial concentration of F2 and I2 are 0.20 molar and there is initially no product present, what will the concentrations be at equilibrium? So it gives us initial concentrations of the reactants. So let's write down the reaction. The reaction is F2 plus I2 yield 2 moles of IF. So it gives us the initial concentrations and then asks about the concentrations at equilibrium given that KEQ is this value. So that presentation is a classic icebox problem. So ICE is an acronym for initial change and equilibrium. And so you construct this so that you can kind of see what's going on in the process. Where do you start? What's going to happen? And then at the end of the process, once you reach equilibrium, what will the shift in relationships be? And then you can set those equal to your KEQ value. So we'll go ahead and complete our icebox problem here underneath. So we'll go I, C, and E. Did that show up? Nope. All right. Initially, we know that we have 0.20 molar fluorine. The iodine is the same thing, 0.20 molar. And the iodine, it said that, or the iodine monofluoride, that there was none of the product present at the beginning, so it's 0 molar. Now, since there's no product present at the very beginning, but there are reactants present, you know the equilibrium is going to have to shift towards the products, right? Some of these reactants are going to be consumed, and some of the products are going to be formed. So I know the reactants are going to decrease by some amount, so I'm going to call that change negative X. Every time I use a fluorine, I'm also going to use an iodine. So if fluorine decreases by X amount, iodine is also going to decrease by X amount. And since the mole ratio is 1 to 1 to 2, if I use X amount of fluorine and X amount of iodine, then the iodine monofluoride is going to increase by 2X. And then that means that at equilibrium, fluorine will have decreased from 0.2 by X amount to be whatever concentration it'll be at equilibrium. So at equilibrium, it'll be 0.20 minus X. Iodine, same thing, 0.20 minus X. And iodine monofluoride will go from 0 up by 2X, so it'll just be 2X. Then I can take these values, the equilibrium values, and put them into a KEQ expression, where KEQ is that value that was given to me initially. If I solve for X, then I can plug X back into these equilibrium equations or equilibrium situations and find the concentrations at equilibrium. So we will say equilibrium expression for that would be KEQ equals the concentration of IF squared over the concentration of fluorine times the concentration of iodine. So I'll plug these values into that expression. And this is squared because of the 2 in the coefficient. Oh, and we know KEQ. KEQ is 0.00872. So we'll plug all of that in. So it's going to be 0.00872 is equal to 2x squared over 0.20 minus x. And that's going to be times itself again, right? 0.20 minus x times 0.20 minus x. And so to save ourselves some trouble, I'm just going to write that as 0.20 minus x squared. That also makes the math just a little bit easier. Because now I can take the square root of both sides and I get 2x over 0.20 minus x is equal to whatever the square root of 0.00872 is. Which is 0.09338. And we'll multiply the 0.2 minus x over, distribute that out. So you end up with 0.01868 minus 0.0934x equals 2x. And add that 0.0934x over to the other side, then divide the 0.0934 over to there, and we end up with x equals 0.0089. So that's our x value. Now, the x value isn't really an answer. I mean, it was the answer to our unknown from this whole series of work, but it's not an answer in the fact that it's not one of the concentrations at equilibrium. So we're going to take that x value, bring it back over here. So the iodine monofluoride at equilibrium will be 2 times this x value, and that comes out to be 0.01 something, but 178 probably. But with sig figs, we're going to round it off. So we're going to say 0.018, and that's moles per liter or molar, like that. Then, yeah, 0.20 minus x. So these guys are going to end up having the same value. And so 0.20 minus x, where x is 0.0089, rounded to 2 sig figs, we get 0.19 molar, and that would be the answer for both the fluorine and the iodine. If you're my student, I would encourage you, take these values that you found, plug them back into this equilibrium expression and see if you calculate KEQ now, is it very close to this number? Because of the rounding, it might not come out to be exactly that same number, but it should come out to be really, really close.